Hi, welcome to the lecture on Git version control. My name is Marcel Cook, and this is the first introduction to Git. So, version control systems, how to deal with code in a sensible way. Let's start with an example on how you work together on a project report. In this case, we call it the project report case. Imagine you have a project with 4 people and you write one report. Generally, it's going to look something like this. So report final, then MK Marcel Cook does something to the report, saves it like this, and then you have a report final MK something else, report final 2, and then, oh no, we have to do something else again. Okay. We can all agree this is horrible. We don't want to do this, especially when you're writing code with each other. When you write code, you have a lot of files generally, so this becomes a mess. So what is a version control system? A version control system is basically a tool that can help you keep track of changes of your files. And also a means of sharing your changes with your team members. You can collaborate on it. So there are multiple tools or constructions that you can use, how you can collaborate in an efficient way. We come back to that later in the lectures. And very importantly, you can revert back to an earlier version. It is very handy that if you have moved on in your implementation, that you can and you're on a dead track basically, and then you can revert back and start over again. This is very helpful and actually something that's used quite often. Store all the files in a database called a repository. And so repository is the place where everything's kept. So the files and the changes that has been made to the files. Let's show an example like we could do with the report case we saw before. So here is the initial commit, basically. So the first version of the report is entered in the repository. And then we add and change things to the report. Here you see that Hakim added a message section, Theo added the introduction, Marcel fixed some typos, something else, and so on. And at some point you can say, okay, this is a special change, and we give that change a name, a tag. And in this case, the tag is v1.0. This is handy for later reference as well. But we come to that later in the next lectures. Okay, and this you can still continue working on it. So, but what happens here, and what you see is on the left side you have a timestamp depicting when it was entered, the change. In green you see a magic number that is used for later for referencing. Then a name of the person, or like an identifier of the person that did the change, and a command. And this command is very important to show what happened. And so if you walk through the repository and you walk through the commits, then you can see later on what happened to this file, and that you can get a clear view on what's the status of the file. So for instance, you are on a holiday, you come back, and then you can revert back to this commit log, and then you immediately know what happened to it. Very useful. If you check out a repository or clone a repository, you will always get the latest version by default. You can ask for a specific version, but it's not standard. But it is possible. So a repository it can come in a distributed and a centralized fashion. And so a centralized fashion is what you see on the left here in the picture. We have one repository and all collaborators have a working copy on their workstation or PC or laptop, what have you. On the right side, we see a distributed version control system. There, basically, everyone has a complete copy of the repository. This is something that is used more and more often, and basically this is now the most common used type of version control systems that are out there. The red dotted line gives the division between what is remote and what is local. So on the top you have a remote server, and in our case that's something called GitHub. I will demo that later. And you push and pull back and forth to GitHub from your own laptop. And all of you are going to do that in the assignments later on. So there are a lot of versions control systems out there, but we are choosing for one, and that's the most commonly used nowadays, and that's Git. It is a distributed one. You can look up the others if you're interested, but Git is the go-to version control system nowadays. So let's talk about data transport in Git. So on the right you see again the picture on the distributed version control system, and on the left you see a schematic index on what kind of data locations there are in Git. In gray on the left you see a workspace. That's what you see when you work on files. These actually that's on your file system. If you open up an editor, you edit your file, that's where it happens. In green, the local repository is the database that is stored on your machine. You will never look into it directly, but you interact with it using the commands you see in the arrows. We will come back to that later, and we will explain in detail what these commands do and what is a good workflow in this case. On the right, you see the remote repository. That is, in our case, GitHub. Can be also a coworker's laptop if you want, but that's a bit too complicated, and it's generally not used in this way. Here again, a red line depicts what is all local to your laptop on the left side, on the left picture, and what is remote to your laptop, and that is, in our case, GitHub. I want to ask you to create an account on GitHub and make sure that the following extensions are installed in Visual Studio Code. That's Git Lens and Git Graph. Those are very handy to work with to get insights in your repository. I will now demo GitHub and how to clone a repository. Here you see the GitHub front page when you just logged in. In assignment 0, I asked you to share your GitHub user account with me so I can add you to an organization. So how can you get to this organization when you just logged in? You click on the top right on your profile icon and you go to your organizations. Here you see this organization. You click on it and you're on the front page of the Python programming organization. Okay, for the demo I want to clone a repository, and here in the repository list you can see that there's an examples 2021 repository. This is the one we want to clone for this demo. So here you see the file list. There's only one file in README, and here you see the contents of the README. It's rendered Markdown. So how can you download this repository? So there are multiple ways, but I want you to use only one way. You go to the top right here on the green button, and you press on it. Then you have a clone section and a download zip section. Download zip we're not going to use. We want to clone the repository so we can have that on our own laptop and interact with it. Make sure the HTTPS box is tab is checked, and you can copy and paste the URL or click the copy button. So now we switch over to Visual Studio Code to see how we can clone this repository using that. I opened up Visual Studio Code to show you how to clone the repository. Start by typing Ctrl-Shift-P to get the command window. This is Command-Shift-P for Mac users. And type git clone. Now provide the repository URL. You just copy it from GitHub. Press enter. It asks you to provide a location where to store the repository. Do this in a location that's convenient for you. Now asks to sign in using GitHub. This is something we don't want. We want to use a username and password combination, so press cancel. Type in your username and your password. Press on open to view the repository you just downloaded. Here you immediately see the README file that was in there. As a second assignment, I want to ask you to configure your display name and email on your laptop. So as a first assignment, I want you to configure your Git installation on your laptop. So it's important to configure a display name and a user email. These things both are used to identify you to GitHub whenever you commit files to it. And next, you can clone the course examples repository like I just showed you. You can do this using Visual Studio Code, or if you're up to it and you're familiar with command line, you can also try to type in the Git commands by hand. There's a command line interface for Git. I will show you how you can how it looks like to configure your username and email. So you can press Ctrl backtick. You're presented with a command line terminal on the bottom. You type in the commands. So git config global username, and then this is my username. So for you, you have to, of course, type in your own name. That would be handy. And the user email. This is the email I used for signing up at GitHub. And there you have it. I've entered a table in the sheets where all commands are depicted or are shown, and a small description on what it does. These are command line commands, but the terminology is the same all over Visual Studio Code. Okay, this is the end of the introductory part. Next time we're going to dive a bit deeper in what all the commands here mean and show you some examples and some recommendations on how you can work together efficiently. Thank you.